Okay, this is the fourth and final video on trigonometric integrals. So I've been following James Stewart's 6th edition calculus, and these four videos, A, B, C, and D, have been on strategies for integrating combinations of powers. So the first one was on combinations of sine and cosine when one of them is odd. And the second video was combinations of sine and cosine when they're even. And then the one I did just before this, 8.2c, was strategies for integrating powers of tangent and secant when secant was even. This final video in integration strategies for trigonometric integrals is when tangent is odd, when the power of tangent is odd. And the key formula to know here is that the derivative of the secant of x is secant tangent. And again, I've tried to come up with mnemonics. So the formulas for the previous video were, knowing that secant squared x equals 1 plus tangent squared x, and also that the derivative of the tangent of x is the secant squared x. That's from the previous video. So here, the derivative of the secant of x is secant x tangent x. And I don't know that it helps, I've kind of played up with cosine is strong and secant is strong, which is 1 over cosine. And so the fact that secant adds on to it, I don't know if that means it's strong, it's adding muscle, it's going on a tangent, I don't know. But this is a formula to know for this situation. What is the situation again? The situation is we're integrating tangent secant to various powers when the power of the tangent is odd. Okay, that's what we're doing. So here's an example from the book. So here you can see that tangent is to an odd power. Secant is to an odd power as well, which is very convenient. But of course, this is an example from the book. So what we're going to do is we're going to pull out one tangent and secant from that, right? We're going to pull out a secant and a tangent. So here's how that looks. Brings the tangent down to an even number, brings the secant down to an even number, and then we've got this flying out there. Why did we pull that out? Because remember, on the previous screen, we just saw that the derivative of the secant is secant tangent. And so by pulling that out, we have a du in the making. So the next thing that we're going to do is we're going to get everything in terms of secant, right? Because this is the derivative of secant, so we're going to get everything in terms of secant. The way we're going to do that is by taking this tangent here, and this is the formula we learned in the previous video, that the tangent squared x equals secant squared x minus 1. So and of course it has to be to the total to the fourth power. So secant, so tangent squared x squared is tangent to the fourth power x. So tangent squared x is secant squared x minus 1. So that's tangent squared x to the second power gives us to tangent to the fourth power. Okay, does that make sense? So again, this is tangent squared is tangent to the fourth power. There's the secant x, and there's the thing that we pulled out. All right, now that we've got everything in terms of secant, we can do u equals secant x, and remember du is secant x tangent x. Remember the dx this time. So we can then substitute this in, and we've got u squared minus 1 raised to the second power times u to the 6th power du, because remember, all of that is du. And that's something that we can deal with. That's easy. We know that, right? Let's go ahead and multiply it out, shall we? So u squared is, well, actually we've got to multiply first, outside, inside, last, right? So first is u squared. Outside, inside is minus 2 u to the squared. Last is negative 1 times negative 1 is plus 1 times u 2 to the 6th, right? Oh, I forgot the parentheses on this side, but you can handle that, right? Multiplied out, 6 plus 4 is 10, 2 plus 6 is 8, and then u to the 6th at the end, and now we've got a nice, easy problem. So that's going to be 1/11th u to the 11th, because let's do it backwards. Using the fundamental theorem of calculus, we can go backwards, right? So 11 times 1/11th cancels out, and subtract 1, and we get 10. All right? What about u to the 8th? We got the 2 in front. Don't forget it. Keep track of these things. So 9 times 1 to the 9th cancels out, and we take down the 1 power, and we get u to the 8th. Yes, that works. Okay, what about this one? 7 times 1/7 goes away, and take it down 1 power. We've got 6. All right, there you've got it. It's right there. So now we just substitute the secant back in, and voila, there's the answer. 1/11th secant to the 11th power x minus 2/9 secant to the 9th power x plus 1/7 secant to the 7th power x plus constant. Quod erat demonstrandum, and we've done it.